what you know about absolute value. In a moment, we're going to give the actual definition, the mathematical definition, but tell me what you already know about it.
Like any number but positive, right?
Okay, so first of all, it always has to be positive. Okay, what else do you know about it?
Distance on a number line.
It represents the distance from 0 on the number line, and that's why it's always positive, because it's a distance. Now, what is, those are exactly right, there's nothing wrong with anything you said, but we have a definition for absolute value. The definition for absolute value says that the absolute value of x is x if x is greater than or equal to 0. What does this mean? The number is positive. If the number is positive, then the absolute value of it is itself, right? What if the number is negative? What is the absolute value of x if x is negative? Exactly. Let's say the opposite, same thing, but when we say negatives and absolute value, we get all like, oh. So if this number is negative, when you take the absolute value, you get the opposite of it, right? That's your definition for absolute value. There are times, if you have really complicated absolute value problems, which we're not going to look at today for sure, but if you have really complicated ones, sometimes the only way to really do them is to actually apply the definition, and then you can work it all out. But usually we don't need the definition to do our problems. Somebody said that the absolute value is the distance from 0 on the number line, and that's true. But what if I had two just random numbers on the number line, like A and B? How could I express the distance between them? Alex?
The absolute value of A minus B.
Okay. Which, Alex, would be exactly the same as the absolute value of?
B minus A.
Exactly. So the cool thing about absolute value is that subtraction is actually commutative if you take absolute value. Now, just out there in the real world, 5 minus 2 is not the same as 2 minus 5. But if you put it in absolute value, it is. So the absolute value of a difference gives me distance on the number line. Let me say that again. The absolute value of a difference gives me the distance on the number line. Now, let's use that idea to solve this problem. Now, I want y'all just stop for a second. I know that if you were walking out to your car and you found this problem in the parking lot, I know how you would solve it. You would set up two equations and solve both of those. And I'm not going to argue with that. It's perfectly okay. But that's not how I want you to think about it today. Today I want you to think about this problem from this distance idea. Because what you've got here is the absolute value of difference. Would you agree with me? And what did we just say that was? The absolute value of a difference is the distance on a number line. So here we go. Here's 4, here's x. According to this, the distance between those two numbers is 5. So where's that got to be? Where's x got to be?
9.
9. But wait a minute. Could this have also been x? That distance is still 5. So what's this x? And those are the answers to the problem. Now I know you can get that other ways. Right now, just bear with me. This is for why. Because a year from now, day one of your calculus class, you're going to be using this idea to talk about limits, and I want you to have some idea what she's talking about, okay? This is the distance between these two numbers on the number line. So whatever x is, it's got to be 5 units that way or 5 units this way. -1 and 9. All right, let's step it up a notch. What about this? What do you think about this little absolute value inequality? Now, don't panic. First of all, that's not even a minus. Doesn't it need to be a minus? Oh, it does. It does. Can I make it a minus? Could I rewrite this with a minus? How?
-2.
Exactly. So x minus -2. So now, is it a difference? The distance between some number and -2 is more than 6. The distance between some number and -2 is more than 6. So where's that number going to be out here? 4? Or where's it got to be back here? -8. Now be careful. At those 2 points, the distance is exactly 4. I need to be more, exactly 6, sorry, exactly 6. I need to be more than 6. So where am I on this number line if I'm more than 6 away? Outside. This says that the distance between some number and -2 is more than 6. So it's got to be past 2, or it's going to be past 4, and past -8. So what's my answer?
X is greater than
Let's use interval notation, -infinity to -8. Union, that's the mathematical symbol for 4.
4.
Beautiful. All right, let's try one more. I don't think I have one down there, but just squeeze it in somewhere there. Real quick, we'll try one more. How about, and just squeeze this one in. Origin or someplace. All right, so this one looks a little different. Really can't handle a number here. So I'm going to divide everything by 2. Now please don't get all, it's perfectly legal. We're going to divide everything by 2. So now what does our problem say? Here's my number line. It says the distance between some number and 5 halves is less than or equal to 7 halves. So where's that number going to be? If we go this way 7 halves, we would be at, well, it would be 12 halves, so 6. And if we went this way 7 halves, we would be at -2 halves or -1. Now because it's or equal to, I'll go ahead and color those dots in. Hopefully that makes sense. That's where the distance is exactly 7 halves. Now be careful, this time I need my distance from here to be less than 7 halves. So where will I shade?
It's inside.
In between. This is where it's less than 7 halves. That's where it's more than 7 halves. This is less than 7 halves. So my answer is negative 1, 2, 6.
Oh.
Gus, what do you think about that? Aren't you glad you got up this morning so you could have this conversation about absolute value? Yeah, we're gonna practice some of this. All right, this might help too. Write as an absolute value. So now you're gonna take these words and you're gonna write it as an absolute value problem. The distance between x and 6 is 7. All right, what's that gonna be? Someone tell me.
X minus 6. See what's up.
Perfect, put that x minus 6 in absolute value, because we have to go both ways, forwards and backwards. So put it in absolute value, and that's it, that's beautiful. The distance between negative 3 and x is less than 5. What do you think about that one?
X plus 3 plus 1. Is less than 5.
Did everybody understand why that's a plus? Technically, it's this, but we'll go ahead and make it a positive. The distance between x and a is at least d. The distance, I'm going to put an absolute value, between x and a, so what'll go in here? X minus a, okay, is at least d. Greater than or equal to d, perfect, yes.
You said the order didn't matter. You said that.
No, it doesn't.
It's like if you said A minus.
I almost always, they'll practice, maybe even always, I hate to use the word always, but like I like to have my variable first. It's like when I write a regular equation, I usually have my x's first. But yeah, this is exactly the same as those are identical. Okay, we okay with that? All right, again, when it comes time to your homework or a quiz or something, unless it specifically says use distance, I don't care how you solve your problems. I just want you to be aware of this idea. All right, midpoint. Good Lord, you've done midpoint year after year after year. How do we find the midpoint between C and D? What do we do? How do we find midpoint? Yep, Alex.
Add the two together and then divide by 2.
Bingo. So, Alex, I'm not good at memorizing stuff. I don't know what to memorize. I know there's a midpoint formula. When you tell me to add 2 things and divide by 2, what am I really doing?
Your average.
Averaging them. I want you guys, please get in the habit of thinking about midpoint as average. Because when we start sketching our trigonometric functions, we're gonna have all kinds of wacky numbers. And if you just think about averaging, I think life's gonna be better. So the midpoint is C plus D divided by 2. Perfect. This is on the number line. So what is the midpoint of 6 and negative 9?
Negative 1/2.
3 halves or 1.5? Oh boy. Negative 2/3 and 7. Now, Alex said we're going to take negative 2/3 and add it to 7. What do I need? I need a common denominator. So that's negative 2/3 and 21/3, which will give me 19/3. And then I have to divide by 2. When fractions are involved, I'd rather not divide by 2, I'd rather multiply by 1/2. So the answer is 19/6. Notice I didn't freak out when I saw the fraction. I just did what I know how to do. Now, if we go to the coordinate plane, here we were talking about just two numbers, just regular numbers on the number line. If we go to the coordinate plane, where we have a couple of points, ordered pairs, we find midpoint exactly the same way. We average the x's, so add them up, divide by 2, add them up, the y's, divide by 2. Nowhere in your life is someone gonna say to you, what's the midpoint formula? No one cares. They're gonna say to you, find the midpoint. So you gotta know how to find the midpoint. Average your x's, average your y's. Now, what if you wanna find the distance between these two ordered pairs? Do you remember your distance formula? You gotta remember this one. This is what?
Negative b plus or minus.
That's the quadratic formula.
Yeah.
Don't you ever forget that one either. We need
Got
that.
that one locked.
Then we use the quadratic formula to solve a quadratic equation, right? So that's a different category. We'll talk about it in a couple
X2
days.
minus x2 minus x1.
We are finding the distance
Ooh.
between these 2 points.
Hell no,
So
X plus.
we're gonna subtract our x's and square it. Now, could this be x sub 1 minus x sub 2?
Yeah.
Yes, because I am squaring it. So does it really matter? No. No, just find the difference between them and square it. And likewise with the y's. When you square it, the negative will disappear. So it doesn't matter what order you subtract it. But you gotta do the x's with the x's and the y's with the y's, right? All right, so now let's do that. Here are 2 points. Take a minute and see if you can find the midpoint and the distance using these 2 points. So you're gonna find the midpoint and you're gonna find the distance. And by the way, you might remember this from geometry. The distance is indicated with an A and a B with nothing above it or below it. That means a distance. That's a length. This is the length of segment A and B. Oh my goodness, we are too calculator dependent. Guys, you can't do this problem without a calculator. Ay, 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 ay. I know, I pull mine out way too often. I'm at you. If not, let's talk about it. Dan, how you doing over there, okay? Everybody okay? All right, try the next one. No, we still don't need the quadratic formula. Don't use the quadratic formula. We still don't need that. this one's got some decimals, so if you need to use a calculator, you can, but I think you can still do it without a calculator, but maybe not. How's that midpoint look? Is that what you got? Here's fractions, here's decimals, doesn't matter, whichever, which you switch. And then decimally, I got 1.581. And exactly, I got root 10 divided by 2. And I got that by changing my decimals into fractions. So 3 halves squared and 3 halves squared and 1 half squared. This would be considered just vocabulary, exact answer. And this is your decimal approximation. In our AP work, we are asked to be exact whenever possible. If we are not exact, if we are rounding off, we always round to the 1,000. That's kind of the AP rules. Okay? Everybody all right with that? Everybody got distance and midpoint down okay? All right, let's look and see what's happening in number 9. Okay. Where do I know? So I got a couple points off there, A and B, and I do not have any idea what A is, but I know the midpoint is -3.6, and this is the 0.24. Obviously, I haven't plotted them appropriately, I just slapped them up here on the board, but that's the situation. Would you agree with that? Now, we somehow have to figure this out. So what pops into your head? Let's see. Bennett, what pops into your head?
Distance formula.
Distance formula?
Like
Now,
use it.
be careful. Tell me how you would do that. Tell me how you would use that.
Like you could use it to find M to B. Like
I
distance
could
between M and B.
definitely find that distance, that's right, but remember, that distance is going to be a radical. If I use the distance formula, okay? Then what would I do with that distance? Okay. And did you say that would be difficult?
Yeah.
Yeah. Yeah, because if I tried to set that up with an equation, I'm gonna have two variables in that equation, and I don't like that. I'd have an x and a y unknown. I think there's another way. You're on the right track, then. Keep in mind, that's the midpoint. So what do we know about midpoint? It is average. So we know that -3 has to be the average of x and 2, right? So the average of x and 2, that would be the average of x and 2, has to be -3. Can I solve that equation? Yeah. So x plus 2 equals -6. It looks like this is -8. And then similarly, the average of y and 4 has to be 6. So it looks like y is +8. Now, I totally love Bennett's idea of using distance. But use it this way. How far is it from -3 to +2? +5, right? So if from here to here is +5, then doesn't from here to here also have to be +5? But since I need to go backwards, I will not add 5, I will subtract 5. What's -3 minus 5? 6 to 4 is -2. So backing up, I'll go +2. So that distance idea is perfect, do it one letter at a time. One letter at a time. Okay. Find the area and perimeter of this triangle. Again, I am not plotting these points. You certainly could if you wanted, but I don't need to do that. But you can if you want. All right, perimeter. What's perimeter mean?
All sides.
Add up all the sides. So, Fred, that row over there, I want you guys to find CH. Okay, you guys do CH. You guys here in the middle, I want you to find HS. And you guys over here, I want you to find CS. So you're doing a distance formula, distance formula, distance formula. When you got it, tell me what it is. We'll add them up and that'll be our perimeter. Avery, you got an answer over there?
I got 6, like root 36.
For this guy right here?
Yeah.
Tell me how you did that.
I used the distance formula. So then I did, -5 minus 6 squared plus, 3 minus 1. Oh wait, I got it.
You want to revise your answer?
Yeah.
Which you have?
41.
Yeah, 41, that's what I got. Fred, you good? How about you guys in the middle? You had HS, what did you get? You're kidding me. Well, that's okay, right? At least we got at least an isosceles triangle. What did you guys get on the bottom? Root 82. So the perimeter, I heard somebody thinking back there, I love it when you think. The perimeter is 2 root 41 plus root 82. Those do not add. These two are the same, so I got 2 of them, but that one can't be added, right? So that would be my exact perimeter. area. But we don't even need any fancy way to find area, because what do you notice about, we call this side A, and we call this side B, and we call this side C. If I square that one, I get 41. If I square that one, I get 41. And if I square that one, I get 82. Would you agree with me?
Yeah.
So what's going on here?
It's the right triangle.
A squared plus B squared equals C squared, so we have a
Right triangle.
right triangle, and the right angle is right there.
Yep.
And the area of a triangle is 1/2 base times height. And the base and the height, remember, are always the perpendicular sides. So this thing happens to be the way I drew it, laying on its hypotenuse. But the perpendicular sides are always the base and the height. So the area of this triangle is simply 41/2. Totally cool. How are we? Great? All right, let's look at the next one. We are going to prove that the diagonals bisect each other. Now, this time, it is going to be necessary for me to at least reasonably plot these, because if you give me 4 points, I don't know which ones are sides and which ones are diagonals unless I can get a visual, right? So I'm gonna have to kind of plot these. So -7, -1. Doesn't have to be perfect. I'm just trying to get some sense of what it looks like. -2, 4. So here's my quadrilateral. My job is to prove that the diagonals, and everybody remembers these are diagonals, right? The diagonals bisect each other. Okay, so who has an idea? There's actually more than one way we could do this, but who has an idea?
Find the midpoints if they're the
Find
same.
the midpoints and see if they're the same. All right, what is the midpoint of QS? Well, let's average. -2 and -2 is -4, divided by 2 is -2. 4 and -6 is -2, divided by 2 is -2. Don't let me make a mistake, is that good? And then I gotta do the same thing for PR. -7 and 3 is -4, -2, -1 and -1, If they have the same midpoint, does it make sense to you that they bisect each other? What kind of quadrilateral has diagonals that bisect?
Doesn't have to have right angles. It can be like a rectangle or a square, though, right?
Do the diagonals of a rectangle bisect each other? Yep, they sure do. A square? Yep, they sure do. A rhombus? Yep, sure does. It's a property of parallelograms. So
Oh.
any parallelogram is gonna have diagonals that bisect, so that includes all the things you guys said. Okay, perfect. All right. Standard form of the equation of a circle. Anybody happen to remember that? What the maybe you can't remember like the standard form, but can you remember an example of the equation of a circle? Can you give me an example? That's the equation of a circle. That's what they look like. That's called the standard form. Now certainly we could FOIL it all out, but this is considered the standard form. Where would the center of this circle be? 2, -1. And what is the radius of this circle? Square root of 17. So, in terms of the formal standard form, we say x minus h squared, does that sound familiar? Plus y minus k squared equals r squared. That's the equation, the standard form of the equation of a circle. The center is hk, just like you said, and the radius is the square root of that number. So this is an example. This is the actual standard form.
Wait, so what do the h and the k represent?
The center,
Oh. But they're the same, are they the same variable? Like they're both for the same?
yeah, the center is a point. When
Oh.
you draw a circle, there's your center, it's a coordinate, it's an
Okay.
ordered pair.
So like the h is just like the x coordinate
Yeah,
of the center?
the h is the x coordinate in the center, and the k is the y coordinate in the center.
Okay.
Yeah. All right, so now you're gonna write a circle. Write the equation of a circle with the given center and radius. Well, kids, this is easy. If the center is -3, 5, then what are we gonna have here in our parentheses? X plus 3 and y minus 5, and we're gonna square both parentheses. And then what's gonna go here? Remember, it's r squared, so it's 2√6 squared. Now when you square that, you gotta square both pieces. So this would be 4 times 6, so this is 24. All right, you do B. Write the equation of the circle with a center at 5, 0, and a radius of 9.1. Aubrey, what'd you come up with?
I came up with x minus 5 squared. I just wrote y squared plus y
Perfect.
squared.
Perfect, you don't need that. If you wrote y minus 0 squared, that would be totally fine, but we don't need it, right, since it's 0, okay?
And then equals 82.89.
And she got that by squaring 9.1? Because in our general form, this is r squared out here. All right, 14a, too easy to even write down. What's the center of this circle? 3, comma, -1/2. And what's the radius?
Root 18.
Ooh, be careful, yes, but what about the square root of 18?
Root 2.
it breaks down, and we always want to break down our radicals, that's an expectation. Simplify everything. So square root of 18 is 3 radical 2, yeah. Oh my. Oh my God. Oh, first of all, do you recognize that this is a circle? Yes, it's not standard form, but think about this for a second. If you FOILed all this out, wouldn't you have an x squared and a regular x and a y squared and a regular y? So this is a circle, but it's been all FOILed out. If we want the center and the radius, we're gonna have to turn that equation into this form. What's your thought? Have you done that before? It's not hard. Have you done it before? What's your idea?
Wait, so do you have to just like? Actually, no, I'm confused now.
Take the 14 to the other side and then your y's next.
Absolutely. He's gonna complete the square, that should sound familiar to you, because he has to have squared quantities. He has to turn this gobbledygook into this. So he has to create the squares. And we do that by completing the square. So he said, get rid of the 14, that has nothing to do with anything, get it over there by itself. And then put together your x terms and your y terms. See how I've done that? Now, I left a blank here because I have to figure out what to put there so that this will become this. Do you remember how to complete the square? Do you remember how to find the number that goes there? How do you do it, Robert?
I did 12 divided by 2, and then I squared.
Bingo, that's it. You take half of this guy and square it. So half of 12 is 6, squared is 36. So she got her 36 there. And what did that do for her? It made this guy right here, x plus 6, quantity squared. X plus 6, x plus 6. Now, she's got to remember, though, that if she stuck a 36 over here, she's also got to stick one over here. This isn't equation. Let's repeat with this one. Who can we get here? Scout, can you figure out what goes here?
25.
25. Half of 10 squared. Very good. So that makes that parentheses y plus 5 squared. And then what's it gonna equal? Yeah, I got 75, but that would be wrong. How's that sound? All right, so what's the answer to the question? What's my center? Negative 6, negative 5, and my radius is? 5 root 3, square root of 75, which is 5 radical 3. Okay, you and your partner, DC, tell me the center and the radius for problem C.
Would you take out, or would
2.
Yeah, it's just you divide by 2 equals 2y.
Oh, okay.
It'd be negative 4 or no?
No, when you multiply by 2. So you get negative 2. And then multiply by 2.
Notice that because there was no y term, there's a y squared, but there's no y. It's like that one we had a minute ago. You don't need to mess with it. It's just going to be 0. That coordinate's going to be 0. I got 2, 0 and root 2. How about you? All good?
Wait, we got negative 2, 0. I think it's something wrong.
Okay, did I copy that right? Yeah, so this was x squared minus 4x. So I completed the square and added 4. So that's gonna factor into x minus 2 minus 2. That's a minus right there. Right?
Yeah, that's where I'm at.
All right, let's take a look at 15. Write the equation of a circle whose diameter, we know what that is. So I got a circle, got a diameter, and the endpoints are 2, 7, and 6, negative 13. And my job is to write the equation of the circle. So I need to come up with something that looks like that. So my ultimate goal is this. Tell me where to start. What do you want to do here? Avery?
Find the midpoint, that way you find the center of the circle.
Okay, that makes sense to everybody. That seems pretty easy. So here's my center. Midpoint is average. So 2 plus 6, that would give me 4. It gives me 8, half of that would be 4. 7 minus 13, 7 plus negative 13 is negative 6. Right by 2 is negative 3, okay. So that's my center, so I can automatically come up here and say x minus 4 and y plus 3.
Yeah.
Okay, now what? Almost done.
You find the distance between the diameter and then divide by 2.
So one option, he says, whatever I write here, this is gonna be r squared. So he said I can find this distance right here and divide it by 2, and that would be r. What else could you do?
Just find the distance from the
Yeah,
midpoint.
it doesn't matter, whatever flips your switch, right? So I can find this one, they're gonna be the same, hopefully. And I can also find this one, just remember if you do this one, you have to divide by 2. So I'm gonna go ahead and do this one, right here. So that's gonna be the square root of 6 minus 4 squared, this is my distance formula. 6 minus 4 squared. And negative 13 minus negative 3 squared. So let's see, 6 minus 4 squared is 4. Negative 13 plus 3 is negative 10, squared would be 100. So my radius is root 104. Now don't waste your time simplifying that. Because what goes in your equation? R squared. So it's just gonna be 104. It's not gonna hurt to simplify it, but it certainly isn't going to be necessary. All right? Okay, real quick, we're gonna run through our properties of equality. I can't remember, we may have already talked about some of these. By the way, P2 will be due on Wednesday. P2 is due Wednesday. All right. so here we go. Properties of equality, reflexive. What's a reflexive property? A equals A. You used it all the time when you were proving in geometry. You said AB equals AB or something like that. Symmetric. If A equals B, then B equals A. That's the symmetric property. Transitive. If A equals B and B equals C, then A equals C. You're dutifully writing these down. I think you know them already. Just brush up on them. The addition property, these are all properties of equality. So the addition property of equality says, if A equals B, then A plus C equals B plus C. It's how you solve equations. If you had an equation like this, would you add 7 to both sides?
Good morning, Cathedral. By this interruption, as we come to the end of class before lunch begins, just a quick reminder, at 11:50, Father Joey will be saying mass in the chapel. This is first lunch. Anyone who is available and like to attend is certainly welcome. Now it's pause. We're going to go into the presence of God as we say before lunch today. In the name of the Father, and the Son, and the Holy Spirit. We pray, bless us, O Lord, of these thy gifts, that they are not received from thy eyes, and just bless our Lord. Amen. Have a great rest of the day.
All right, hey, Declan, you need to, when you turn in your homework, honey, you need to rip off the page and not turn it back. I got a couple more homeworks. People turned it in early. Fred, I got yours.
Really, Enzo? Drinking beer in class?
Yeah, you know how it is, bro. Can't get through the day without
Have a good day. I'll see you guys tomorrow.
And so I guarantee half the people who see me sorry, I think you're just like a Modelo or something.
Yeah.
You said